Yeah, recording started. So if you know anyone that's yet to join, please give them a message, drop a message to them, and let them know that we've kicked off. Like I said, my name is Sam, and I'm going to run on through the day 4. So I'm going to run us through the day 4, but before doing that, like we do in our usual version, I'm going to share my screen where we go over our process, just like a quick house house rules. So the first thing first is that yeah, talk about AI Camp. So AI Camp is a global developer community with about 400,000 AI developers, 150 countries. We're currently out of London. We've got chapters across the world. And our vision, our mission is to empower every developer to learn and practice AI from everywhere at any time. And you can participate in the community by joining the volunteers. We are all volunteering for the community. You can also submit a topic. We host in-person meetups everywhere in the cities that we're on. We are in, including here in London. So you can also sponsor a meetup or collaborate at an event. So to collaborate with us, reach out to us at info@aicamp.ai. And yeah, so just to touch on the fact that we also host virtual seminars every week, mostly on Monday. The seminars for next year or the workshop for next year are already on our website. You can look into them to also enjoy it and be a part of it. We also host physical in-person workshops as well, and you also get to be part of it for next year. And this is the London team. That's me, Sam, and we've got David. David took us on the multimodal Gemini flow yesterday. We've got Tibor. Tibor is also going to be taking us through the OpenAI flow today. And I've got Subash that's going to be taking us on day 5 and day 6. I've got Kelvin as well. And the program overview, I know I've talked about this a lot, almost every day. We get the gist now, but in case there's someone joining us for the first time. So this is a program overview teaching foundations, implementation, and mastery use of LLM APIs. So we're talking about all the popular foundational models, both cloud AI, and the open source AI. So the tools we're going to be using or we've been using so far is Google Colab, Ollama, Bedrock, Gemini, OpenAI, and IPX. So we've been trying to make all of our conversation and all of our code tutorials, station them on IDX just to be able to carry everyone along. And this is what the roadmap looks like. We've got foundation in day 1, day 2, cloud AI. We talked about AWS Bedrock, cloud integration. The recordings for day 1, day 2, day 3 are all on YouTube. If you want to have access to it, you can go check it out on YouTube. It's also available on, I created a playlist on YouTube. So it's a playlist, you see all of the videos. So we also put it on the canvas. So the canvas is where we put all of our work. So the task, the assignment, the extra resource, you get them on the Slack canvas. So today we're going to be doing OpenAI integration and assistance and fine tuning. So like I said, all of our daily sessions start by 6 p.m., 30-minute duration, 30 minutes. We advise to come in early, 5 minutes early latest. And we also have tools like Google Account, Python, Slack. I've mentioned this earlier, and communication is going to be on Slack. So this is going to be like an interactive session. So so these are the housekeeping. I know we've been very consistent with the housekeeping. I want to say a shout out to all of you. Thank you to all of you for participating in the housekeeping and making sure that the housekeeping is going well. So this is everything on the housekeeping. So I'm going to call on Tibor to come up on stage to share his live demo. So Tibor is going to be taking us through a live demo. I hope we are all set up already in our environment. You've checked the canvas, you see what is expected to kick off this session, and we should be good to go. So just give us a few seconds as Tibor gets set up and come up on stage.
Thank you, Sam, for the intro. Hi, my name is Tibor. So today I'm going to walk you through how to work with some of the basics of OpenAI APIs, and also we're going to attempt to set up some OpenAI assistants, and gonna give you a little bit of description and information around that. So as you see, my screen is already open on the GitHub page. So this is the GitHub page for the project. There are two ways. I'm just going to show you how to start the project again. There are two ways. Either you delete your previous project on IDX, or I just did that. So I just sort of start from the ground up again. So I just import the GitHub link into IDX. And while that is happening, I'm going to show you how you set up your OpenAI key. So if you already registered with the platform.openai.com, then you can create projects. I'm just going to use a default project. And you click on this settings in the cog icon. And then there should be like an API keys section. And you will create the API key particular to the project that you are currently in. And then you can just say, create new secret key. And you can give a name to the secret. Let's say this is for workshop key. And you can select which project you want to assign it. You can create different permissions. I'm just going to delete the key, so I'm just giving it all permissions at the moment. You can also assign it to a service account. Let's just go with the simplest one. So create a secret key. I'm just going to copy it, done. And hopefully you didn't see much of what's happening. By the way, by the time our environment is starting up. A quick note I wanted to give, because I see a lot of you start later on in the course or the workshops. So we also have all the resources. If you go in the Slack channel, there is a tab here called AISG 7-Day Immersion tab, and then we have all the links in one place, and there are some tasks as well. So this is just a side note while this is loading up. And let's see if it has loaded. Yes, so the project has loaded. It's just going to install some of the extensions, and it's just going to set up the environment for us. I have added a few extra bits here and there, so there might be some new things here. Yeah, it just takes time until everything loads. This has already started, so let's go. And so today we are going to use day 4, and we use this OpenAI workshop document, a Python notebook. And let's see if we can select our kernel. Yeah, so it asks for installing the suggested extensions. So we just click on that. It also wants to the MS Python and MS Tools AI for the Python language. So click on that as well. And just set this up. And just go back to the file explorer. So let's wait until the kernel starts. Now we can select our Python kernel, and we select the lab environment. Just a side note, you can also start your project if you're in IDX. You have an already existing project, you select it and you start it. So if I click here, it will just open up. And because we have updated the Git, so you would just use the Git pull command, and then it would update your code to the newest one. And yeah, so let's go step by step. So first of all, we need to install the requirements. So this is included here. So today we need the request library, which is for making web requests. This is a simple library for using HTTP and HTTPS requests. Pion is just for managing YAML, like YAML formatted documents. This is like a sort of a JSON document, and OpenAI is the library for OpenAI, so we are using the official OpenAI SDK. So first of all, we run pip install our requirements. So it already, because we are in the environment, it should just work. First, it installs the IP kernel package, so we need to wait until that goes through. Just need to wait until everything goes through. Then we have our imports. So OS is just for the file paths. We have OpenAI and the OpenAI method or module from OpenAI. We have the YAML module, so this is for managing our secrets time. I'm not sure actually we need this. It's probably segregated. I don't need it. And requests for, we need to use it for downloading some PDF documents. So this first section is not relevant for the workshop in terms of understanding it. It's really just file managing and reads and prints into a YAML file. So this is how we save our secrets. The most common pattern is using a .env. It's just my personal decision. I prefer it this way, that the secrets are stored here. Let me just import it. Libraries, we run this. So oh yeah, it just defines the functions, and then here I'm calling these functions to load the secrets, and so it will ask for our OpenAI API. I'm just quickly going through this. It saved this here, and the next one. So the simplest way is we use the OpenAI API. So it works very similar to the other clients. So first you need to create a client, you define what is the model you want to use. I think, I'm not sure I need to store, but it's set there to true, and then you set the initial messages. So messages is a list, and within that you have a dictionary where you have a role and the content, where the content is the actual message. All messages write a basic prompt, so let's just send this, and then we have our response here. And yeah, this works. So then a little bit of advanced control of messages, which I wanted to show you, is that you can use a developer role. So messages which has the developer role or the system role, these are not finalized. So usually these are used as to instruct the system to behave in a certain way. So in this case, for example, it's saying to answer to programming questions in Southern Bell, but you can overwrite it. And also it's like, it doesn't matter what is the order, you don't need to make it only one. But the later messages override the previous one. So I have another instruction here to override the instruction as a pirate. And then I also made a system role type request that to insert the keyword lead, and then we have the user input. And so if we send this request, then we will have like, it will respond as a pirate, and we also see somewhere the lead keyword in here. So yes. And the next example I brought up here is sort of an interactive chat. So what an interactive chat, or how a chat is basically interactive, is that you send a new prompt and you just collect up your previous responses, and then sort of that gives the large language model the context of what was in the previous conversation. And this is sort of the very essence of how you can create longer conversations. And then of course you can play around, like where you have a cutoff or what other information you put in. In this case, we will have like a loop of 3 inputs, because it's just very easy to do. So we create the responses the same way as previously, but every time we append or prompt and the response from the assistant into the messages. So that's what I'm going to run here. We have the input here. So say hi to the AI developers, send us a new year message. And then, yeah, we have the first response, and then it wants what can for us today. And then again, we need to wait for the response. Oh, okay. So it is a long text here. I'm not going to read. Oh, that's a good recommendation, which I was thinking as well. So focus on ethical AI. That's just sort of a note that, yeah, it's important that AI is really a powerful tool, and I think it's important for all of us to sort of try to use it in a meaningful way and in an ethical way. So yeah, I think that's a good recommendation here. And can you give us a closing sentence? And I think we have a response here. Wishing you continued success. So this is how longer chains of conversations are happening. And this is the very essence in creating more complex agents that. So the next step is a feature for OpenAI. This is about creating assistants, where assistants are specific agents that can do certain things. You can give them instructions. They have threads, where the threads are these message streams. And they can have a cutoff. You can attach documents to them, and you can also give them different tools and instrumentations. And so let's go through. So this first example is a simple one. So if you run first we create the assistant here. It creates an assistant ID. And then the next step is we create an assistant prompt. So this is the question we want to give to the assistant. We create the thread. So the thread is the message stream that we are interacting with as a single user. Then we are actually creating the message. Then we run the assistant. So this is where actually it can have multiple thoughts. So everything is handled by OpenAI on their backend. Then we can run this model. And what we have is the capital of Francis Paris. So this is a simpler agent. What I want to show you just before I jump off and show you the sort of the research assistant with advanced tool, that everything that we do here is, if we go into the dashboard, you have, like, for example, I created an assistant now. So we should see it, or the time is like 6:20. And we see that this test assistant has been created here. So this is the actual assistant that we have just created with the API. So you can sort of see from here that what you're creating and what you're doing. You have access to its ID, you have its system instructions here, you have its settings and tools. You see its temperature. I think you can also access its messages. Yes, you can also see the messages you have created. So this is the actual thread that we were creating for the assistant. So it's you have access to some tools here. And then let's go and do the last step, which is the research assistant with advanced tools. So what we are doing is we give the code interpreter and the file search tool for this research assistant. Actually, in our prompt, it won't be using code interpreter. So what we are doing is we download two documents from Arcsif. One is the attention is all you need paper. The other one is do not think that much for 2+3 on O1. And yeah, so this first part is just downloading the files for us. So I'm just going to run this. And then we have two PDFs here appearing in our document. Of course, I can't open it from here, so I don't have a PDF viewer. But let's assume it's all right. I can actually show you it on the web view here. Just quickly. We are doing that. Yeah, this is the attention is all you need document. It's around 15 pages. Let's go on. So we already go to our PDFs loaded. Then we are going to instantiate our assistant. So we use the assistants. This is in beta version, so it might break at times, any of these functions or features. I had some trouble going around, but eventually it worked. So yeah, and then we need to upload the file. So what it does is we create these file objects and then we upload them. And then we attach these file objects into a vector store. So what it does, it creates a vector database and chunks down the files into kind of relevant size chunks, which can be searched and read. Like sometimes maybe a PDF document might be much larger than the context window that you can send to the large language model. So it means that the PDF is longer than the maximum length of text you can send in one go. So we created or uploaded our files, and we are creating the vector store, and then we are adding the file IDs to the vector store. And once we have this, then we need to add so we are attaching the vector store to our assistant. And before I go on, we can actually check that the files and the assistant has been created. So let me just go first to assistants. So we have the research assistant uploaded here, and we see the file search and the code interpreter created. We also see that it has access to research document, which is a storage object, which has 2 files uploaded. So that's great. So it seems to be working there. And if we go into the storage, we can also see all the objects that we have uploaded. So this is these 2, actually, or it's probably a duplication in the code somewhere. And yeah, so let's see the next step now. So what we do here is we create our custom prompt. So we want the assistant to summarize the findings in the attention. Attention is all you need paper, and then we create the thread as we did in the previous agent. And then we are going to add the user message in the thread. So that's done. And then we are going to create a run, and then we are going to run the run. So this is just wait until we are getting the state of the run to either completed, failed, cancelled, or expired. Just let's see, it finished. And then we got this summary of the document. So it's a run 6-point summary. The only thing is the output is not formatted, so it's a little bit long like this, but otherwise it looks quite good. It could work on bigger documents or more documents as well. So let's just change the prompt. Give a summary for papers in one compared to provided. So let's say changes. I hope it will work like this, that I just change one detail here. So let's do that. So let's just run the test again. Yeah, all right, it's good. So the phenomenon of overthinking a large language model, which is true. Second paper, comparing these papers, we can see that both tackle the issue of computational efficiency in AI model, but from different aspects. Great. Okay, so this works. And then this last step is sort of, you can see the details of the steps of the run. So this is what I did here. Yeah, what we see here is we go sort of in detail, just check the details. If the attribute exists, then it will display it. for this deeply nested object, which is the step. So let's just run it, and well, it was only 2 steps. So it was created a message, and it created a tool call for the file search. We have finished here. One more thing I would like to show, which I was about to show last time. This is a client. I mean, I use AI to write a lot of boiler code, and of course you can use OpenAI, you can use Claude, and I've been playing around with this, so I'm going to show this before you guys jump in to answer your questions. So this is just one of the extensions. There is Cursor, there are a lot of different extensions. So I'm just going to show you this one. So we have client. This is an AI tool, probably continuously updated. So let's go, and I'm going to add an OpenAI, and I'm not sure. Oh, I think it's still the OpenAI key here. So I'm going to make sure that I got the right key. So just bear with me for a moment. Create a new key here. Although just a warning that it can create a runaway in your, yeah, I didn't have the right key there. It can create a runaway in your tokens, and with that, of your billing. But let's say, so I'm just going to give it permission to do all the things automatically, and give it auto approve. And I don't know if anyone has an idea what we would like to make. Let's limit the request to 30. Write a small snake came in. And this you can see on YouTube. There are quite plenty of this sort of bursts or solutions. You can see the API costs being tracked, the number of tokens for the requests. So the approvals are automatic. So you see the diffs here. The only thing is, in my experience, that so if you have a big complex project, then it goes off tangent, like it doesn't follow your requirements, or not in particular, or it doesn't follow the structure of certain needs. So the more complex your project or your needs or requirements, the worse it will perform. But it's very good if you have clear specifications and sort of a simple boilerplate you need, or you just need to do something repeatedly without a lot of thinking. And it seems to have finished, so let's just try this. Let's see in the Explorer, where is the snake game? I'm just going to activate. Just activating the virtual environment, and then I run Python snake.py. Oh, yeah, it works. Okay, I can't hit. Yeah, well, that looks good, I think. Anyway, that's it. Now the time for questions. I'm just going to stop this. Yeah. Okay. I'm just going to check if you have any questions here.
Yeah, so we've got some questions in the chat, so I think Subhash has tried to answer most of the questions. But if you have any question, you can raise your hands, please.
Yes, Gio.
Hi, Tyler. Thanks a lot for sharing with us. This is awesome. I'm just curious. I saw you demonstrate the fine-tuning code with OpenAI code, but can we just connect with more like a Flask application, so we don't need to run the code from IDX or VS Code? We can just fine-tuning ahead of time, so we can use the GUI to access the fine-tuning code Is that possible?
I think you have multiple questions in one. So I have not been using fine tuning, so I'm not really good on answering that, but I can give you some assumptions. So you can access the OpenAI platform without IDX, yes. And you don't need to use IDX even for developing, and you can use Flask. So we use IDX because it's believed, or we believe, that everyone can work from the same platform and the same tool, and it's very easy to set up. It's very clean. But yeah, if you work personally, you can use anything you like. This is just to demonstrate the basic principles of how to use the SDKs with Python and give you the basic principles.
Okay.
Maybe Subhash can answer you on Pythoning, or if you ask on chat, we can provide you more details or some guides to where to look for.
Okay, thank you.
Kushal, I'm going to answer your question. So what is the advantage of assistance over interactive instructions? So what I believe OpenAI is doing, what they have been doing now, is one is, of course, they have the foundational model, but that just competes so much. Like there's Google, there is Claude, there's DeepSeek, etc., etc. So what they do is they add a lot of features, which makes it easy for users to use. But it's something that you can build on your own. Like you can have your custom vector database, you can make your own controller for the instructions. So that's actually something you can be better than OpenAI. So, and yes, the assistant is like a script where it's just the way the input is controlled. Exactly. And yeah, so it's like it's programmed to execute multiple instructions at once. Yes, that's a good way of thinking. Then what are some of the considerations by comparing different frameworks like Gemini, OpenAI, MetaLlama, etc.? So I think the most important is of course the quality of the thinking. So how it can resolve problems, how it can understand problems. And then you have maybe the pricing, you have the speed. So the speed for the first token and the speed to finish a response. Then you also have, sorry, I just lost my thought there for a moment. So speed, pricing, quality. I think these are the most important. And then, of course, accessibility. There are rate limits as well. I would also add privacy. So and sort of the data control and the security around it, which we can only have second guesses, but I don't know, like there are some companies which are doing a detailed research, or you want to have sovereignty over your data. So whether it's run in the US, whether if it's in Europe or in other countries. And yeah, you can read that in the fine print that it depends on the where it's hosted. What is, so Ryan, you're asking what is a vector store and why use it? So what happens is that when you have an input and when you have an output, it's translated into, first of all, it's tokenized. So tokenized is, as we have demonstrated in the first lesson, is that it's sort of around 3-4 letter long sequences of characters, which is a single token, and it is treated as a single input for a large language model. It can be longer or shorter, but usually it's around 3-4 letters, so a bit less than a single English word in average. And then that is translated into vector. It's like so the input is translated into a vector from the token. So every token is represented by a specific number, and then you have this collection of tokens which create a vector representation of your input. And then it's being it gets normalized, and then every input, every message, every sentence, every concept within words will have a point in a multidimensional space, and there's a feature for it. if you have two things that are very similar, it will be close in that space, and if you have things that are not related, they will be relatively far, and there are different domains. And what vector store does is you store all these embeddings in a database, and you can search it, and you can retrieve it then based on their distance, and it's just very efficient, and it works well. Of course, there's some optimizations around it and that, etc. But oh yes, sorry, Arunavdas, you might be right. I'm not sure. You are saying that there's a difference between vector store and vector database. I might be confused on this, so yes, please complete it on the chat. Chaining appending responses, the message text from Shannon Law. Can we do the same with Gemini to maintain context for the conversation? Yes, so this is supported by all the models, so you can chain and append responses. The formatting might be a little bit different, how it works. And then there are also some open source tools which sort of formalize the access to all these LLM APIs. But then I think you will find that you're just happy to use a single LLM backend, but sometimes you want to play around with different models are good for different purposes. Oh, that was, and I don't know if Subhash, you want to take the stage a little bit for answering some of the questions. And oh, Edmund Bett is asking, what is meant by a pirate? Yar, a pirate is a mercenary who was traveling on the seas and raiding and plundering islands. It was around the 18th century, so that's just a meme. You can see it on the TV, like the Pirates of the Caribbean. Yeah. Okay, we are finished. Let me see if there's another question. Sorry, oh no, Arunavdas, I don't know if there is a difference. Yes, so ARIG is, what is this? Augmented generation. I forgot the meaning of the word, but it's basically you want the capacity for a large language model to sort of look up information from the vector database. So let's say you have a question, but you don't know the specific word. Like, let's say I'm looking for tiger, but I don't know it's tiger. I got the word cat, and then I get everything that's similar to cat, and tiger will be there, and then I get the information about tiger. Any idea which model is good to use to automatically refactor code? I personally use Claude Sonnet a lot, but I think that the new Gemini, the experiment model, is quite good as well. Again, the only thing is usually is around, so it won't maintain like larger concepts that you want to keep or maintain in your project, but it's good in sort of code quality recommendations, etc. But you need to review that it actually makes sense. Thank you for the completion there, Arunav. Retrieval augmented generation, right? Okay, we have finished. Happy New Year for everyone. I think there is no more question, or everything was answered. Ryan,
yeah, I did have a question, just following up on that question that I had asked, right? You said vector store. So all of the prompts that we pass in are kind of converted into tokens, and they are stored into the vector store. Is that different than a vector database? And I'm kind of following up back on Arunav Das's question. And the reason I asked this question was, I think in day 1 or day 2, when we started using prompt, we never used any store to store this information into a database. But today we decided to store some PDFs into the vector store. So are there any differences as to why that was used and why was it not used earlier?
I think maybe the two words are being used by replacing each other, but I'm not sure, so you have to check on this. Okay. And for the purpose of this demonstration, because OpenAI has obstructed away how it works. So you just use an API and you say, okay, I'm going to store my PDF in there. And OpenAI does all the technical details beyond that. So yeah, I think that's it just made it easy. But yeah, so that's the concept, but it basically just stores something for you and the assistant gets. So it sort of simplifies it, or it's one way to handle it. It's just something you can explore and experiment it. I actually wasn't using the OpenAI assistants until setting up today this workshop. So I also just learned about it now.
Okay, we'll explore. Thank you so much, though. Yeah.
Yes, welcome. Thank you, everyone. Have a new year, and see you.
Thank you, everyone.
The 2nd
Happy New Year. See you on the 2nd of January for the next session. Bye.
Take care, everybody. Have a safe evening.
Bye-bye.
Bye-bye.